Welcome back, Crammers, to question 17. Show that root 12 over root 3 plus 2 can be rewritten in the form a plus root b, where a and b are integers. That means do not find the root of 3, simply leave it as is. When dealing with fractions and roots, it's best to keep them out of the denominator by multiplying them by a certain value. Let's find out what that value is. So we write here root 12 over root 3 plus 2. We can see that root 3 is in the denominator, so we simply multiply by root 3. But we don't want to change its value, so we write here root 3 at the bottom. Why is that? Because any value over its own value is simply equal to 1. And anything multiplied by 1 is the same value. But we can see here we still have a constant, which is positive 2. When dealing with constants and roots in a fraction, we simply write its opposite. So instead of positive 2, we write here negative 2 and negative 2. We can see that this fraction is still equal to 1, and therefore it doesn't change its value, it simply rewrites it. So let's multiply. Root 12 times root 3 is root 36. Root 12 times negative 2 is negative 2 root 12. Root 3 times root 3 is simply 3. Root 3 times negative 2 is negative 2 root 3. Root 3 times positive 2 is positive 2 root 3. And positive 2 times negative 2 is negative 4. We can see here that negative 2 root 3 and positive 2 root 3 cancel out. And we can simplify. The root of 36 is simply 6. We can write negative 2 root 12 as is. Negative 2 root 12 over 3 minus 4 is negative 1. So we simply flip. So that's instead of positive 6, it's negative 6. And instead of negative 2 root 12, it's positive 2 root 12. But we are not done. Notice how it says in the form a plus root. There are only two integers here, but in our answer we have 3. So how do we move 2 into the 12? We simply find its square. So negative 6 plus the square of 2 is 4, and we simply multiply it to the 12. So root 12 times the square of 2 is 4. So our final answer should be negative 6 plus root 48. Thanks for watching. Cram, then